PTE Labs, the Magical PTE Studies Center.
As physicists try to explain the masses of particles, they found that if they just tried to inject the mass into the mathematical equations in the most straightforward way, just put a parameter for the mass of a particle right into the math didn't work. It gave rise to quantum mechanically inconsistent features. So it was recognized that you needed to have a more subtle way of introducing mass into the equations that would not spoil the fundamental symmetries, but yet would allow the particles to have different masses. You see, fundamentally, the idea is that all particles begin life as being massless. There's a high degree of symmetry associated with that. All of the particles have the same mass, 0. How do you inject mass without spoiling that symmetry, which is vital for the equations to make sense? The Higgs field does that. By immersing everything in this bath, this molasses-like bath, it turns out that the equations allow you to have your cake and eat it. The fundamental symmetries are deeply preserved, and yet the way in which the particles move, experiencing different resistance-like drag force, allows them to have different masses.
So, continuing our series of lectures on modernism, we now turn to architecture, and in particular to the work of Frank O. Gehry. Now, I'm not going to go into his career in detail. It is enough to say that early on, he was, like other modernist architects, tied to the rectangle, the straight line, and so on. Often their buildings would have this basic shape, and they would just add bits of decoration like splashes of color or pointless balconies. Soon enough, Gehry wanted to break away from straight lines and grid-like designs. He wanted the freedom to experiment with other shapes, curves, and unusually angled roofs. What helped him with this was the computer, which allowed him to visualize and experiment with complex shapes and to work on the whole design as one piece, without the added decoration being thrown in as an afterthought. Architecture as art, if you like. Or sculpture, even. He himself said that he had struggled with crossing the line between architecture and sculpture. Now, I want to talk about one building in particular, the Guggenheim Museum in Bilbao, which I think you'll agree is a masterpiece.
Television, the most pervasive and persuasive of modern technologies, marked by rapid change and growth, is moving into a new era, an era of extraordinary sophistication and versatility, which promises to reshape our lives and our world. It is an electronic revolution of sorts, made possible by the marriage of television and computer technologies. The word television, derived from its Greek and Latin roots, can literally be interpreted as sight from a distance. Very simply put, it works in this way. Through a sophisticated system of electronics, television provides the capability of converting an image into electronic impulses, which can be sent through a wire or cable. These impulses, when fed into a receiver, can then be electronically reconstituted into that same image. Television is more than just an electronic system, however. It is a means of expression, as well as a vehicle for communication, and as such becomes a powerful tool for reaching other human beings. The field of television can be divided into two categories determined by its means of transmission. First, there is broadcast television, which reaches the masses through broad-based airwave transmission of television signals. Second, there is non-broadcast television, which provides for the needs of individuals or specific interest groups through controlled transmission techniques. Traditionally, television has been a medium of the masses. We are most familiar with broadcast television because it has been with us for about 37 years in a form similar to what exists today. During those years, it has been controlled for the most part by the broadcast networks, ABC, NBC, and CBS, who have been the major purveyors of news, information, and entertainment. These giants of broadcasting have actually shaped not only television, but our perception of it as well. We have come to look upon the picture tube as a source of entertainment, placing our role in this dynamic medium as a passive viewer.
The way it started really is I was doing this type of work in the United States where there are a number of lawyers doing it, and had not been done in the UK or the rest of Europe before. And I think the reason it started in the United States was that there was a civil rights movement, and in the civil rights movement lawyers became deeply involved right away, because if you were black and asserted your rights you were arrested. Then some very foresightful funders saw the environmental movement coming along just behind the civil rights movement in time and said, we need lawyers in the environmental movement as well. As a result, one of the main contributors to the environmental movement in the United States have been all these lawyers. Here, there was no need for a civil rights movement, so the environmental groups became expert campaigners. But law really wasn't part of the deal, and never has been. They've never used law strategically. They wouldn't say they have. They haven't. I came here and went around and interviewed people in environmental groups in the UK and Brussels and so on, and was very surprised at the paucity of the use of law. And that's where Klein came from. So bringing the kind of intellectual DNA of work that I had done in the United States into these very different cultures.
Excellent. He said, innovation equals invention, and let me just stop here. Innovation equals invention. Often people mistake these two things for the same thing. Innovation equals invention. They are not. Innovation is something that generates value for the world. It makes something faster, better, cheaper. It gives someone some great satisfaction. An invention is an idea, a technology, a patent. In and of itself, it does not generate value. So these two are not the same thing. And sometimes you see them interchanged, and that's not correct. So innovation equals invention times commercialization. So, and when we look at this equation of innovation, something of value, it requires a new idea, and then it requires someone or some organization that is going to commercialize that idea and to make it of value to the world.